Good morning, folks. This is the lab in week 9 of the course, and it will be administered by the GAs. Of course, I will be back next week and see you on Tuesday. Now, today I'm going to be doing two problems, and one of them is chapter 10, which is called the telescopic mechanism. And in this telescopic mechanism, I will use the point curve and the spherical joint. And then there is going to be an extra degree of freedom that is going to be persisting and does not want to go away when I do chapter 10, and I'll show you a process for eliminating that. The second chapter is chapter 14, and in it I'm going to be discussing C-clamp, very simple problem. There's not much in there, where I use the screw joint in CATIA. We'll talk about this thing later on. So let's look at the first problem that we want to do. It's called telescopic mechanism. So it really consists of three parts. There is something that I call dummy or the ground. I'll call this thing dummy or the ground, which is a path. And the other two parts are an inner tube and outer tube. And the inner tube is sliding in the outer tube. And the top of the inner tube is actually traversing this path. Now, of course, the bottom of this outer tube has to be somehow attached to something. So I have a point. I have a point in the dummy part, and I have a point at the bottom of this outer part, which I'm going to make coincident, and that will lead into a spherical or ball socket joint. Okay, the top one is going to be point curve, ball socket, and the bottom one is going to be ball socket. Now, I'm not going to worry about dimensions. You will see that in order to make that one persistent degree of freedom to go away, I need a point. I'm going to create a point in the dummy part. In addition to the one at the bottom where it's going to become ball socket, I'm going to create a point, but this is the process behind creating that point. But I'm not going to discuss it right now. Okay, we will do that when we get to it. And finally, chapter 14 is going to come about later. Okay, so let's start with the CATIA program, start with the product file. But this is not where I want to do my work, so I'm going to go to assembly design. I prefer to work there when I do problems of this type. Eventually, we're going to have to come to this interface, which is the really DMU kinematics, but let's not worry about it right now. So I'm going to insert. Oh, by the way, let's save it right away. File, save management, save as. In that folder, so let's see, I have a folder called CATIA stuff. Okay, I'm going to create a folder here, and I'll call it telescopic. And this is going to be for the lab on July 15. And we put the stuff here. Okay, insert the first part, which I'm going to call dummy. Insert a new part in there. Excuse me. Right-click properties, dummy, and dummy. Okay, let's make it. So you double click on this line, it'll send you to part design. Excuse me. Okay, we are in part design now. So on a convenient plane, on that horizontal plane, I will sketch. Well, first let me actually first create a point there, because remember we need a point which becomes ball socket. So I'm going to use a global origin to do that. 0, 0, 0. There's a point that's created. Then I'm going to sketch something up here. So first draw a plane, make a plane, offset from here, and I'm going to move this thing up. So I'm going to draw my my curve on this plane. So on that plane, I will sketch. Well, I'll draw a circle. Okay. or an ellipse actually. I'll draw an ellipse. So here in this ellipse, you can draw a circle if you want, makes no difference. There is the center of the ellipse, there is the major and minor axis, there. Okay, exit. So uh, my ellipse is going to be up there. This is parallel to the XY plane because that plane that I created was parallel to the XY plane. It's not a big deal, it's just that I'm just letting you know. All right. Now we go and insert the second part, which I'll do the outer one first. So insert a new part, say no, and I'm going to rename this thing properties into outer. This is the instance name, and the actual part name is down here, outer. And we say OK, and we double click on it. All right, let's make it. So on a convenient plane, on that same horizontal plane, I will sketch two concentric circles, which are going to get padded in just a minute. So there's going to be one like that. This is going to be the outer tube, and there's the cross section of it. So exit, and I'm going to pad it. Okay, higher. Let's see now. Maybe a little bit higher. Yeah, that looks good. Okay, and remember, I want to point at the bottom of this. I want to point at the bottom of this because eventually I put the point at the bottom of this coincident with this point in the dummy, and that becomes a spherical joint. So it's very easy to do that while we're here. So click on the point, but the method is using the circle center, and you go and select that circle, and the point is created right there. So let's go ahead to the product, click on the floppy, save everything. All right, and then we're going to insert our next part. Insert a new part, say no, and this is going to be the inner one. Right click properties, inner and inner. We double click on it, and on the XY plane, or actually let me make my job easier. So I'm going to make it on this plane, just so that I can project that circle, okay? Sketch, let's fit this thing, and I'm going to project that circle so that I don't have to draw that. Notice that it's projected, and then we can pad this. Let me pad it. Okay, a little bit higher. That's good. And on top of this, I'm going to create a point because I want to eventually put it on this path. So create a point. Again, circle center. There we are. The point is created. And we're good. So let's go and save everything. We are in assembly design. Click on the floppy. Everything is going to get saved. And we start assembling. So first of all, I'm going to anchor the dummy part or the ground, okay, so that doesn't move. Then I want to make sure that this inner tube that slides up and down this outer one does not spin, because if I just do axis to axis, it'll just go up, it'll go up and down, and it can also spin. I don't want that spinning motion because there will be an extra degree of freedom, which is not incidentally the one I'm referring I referred to it at the beginning. So we don't want a cylindrical joint here. We're going to make it prismatic. And it's very easy to make it prismatic. You need axis to axis, plane to plane. So here's what we're going to do. Coincidence between the axis of the inner and the axis of the outer. And coincidence between a vertical plane, for example, xz plane of the inner and xz plane of the outer, or yz plane of the inner and yz plane of the outer. That makes a prismatic joint. So let me do, for example, xz plane of the outer and xz plane of the inner, and make it coincident, and this will become eventually a prismatic joint. So now I'm going to put this bottom point and put it at that location. So coincidence between the bottom of that outer part, and there is the point on the ground, and update, and it's going to go there. And now I'm going to take this point and put it on that curve. Okay, so coincidence between the point, the point here and that curve, update, because in order to create a point curve joint, the point must be on the curve. So before I even try to create it later on, I have to make sure that the point that I'm trying to use later on is going to be on that entity curve. Yeah. Okay, very good. So we go all the way up there, click on the floppy. Excellent. And now we're done here. I'll just leave these things on. We go to digital mockup. So digital mockup, DMU kinematics. Get the magic wand out. Here's the magic wand. New mechanism. Auto create. We say, okay, let's see what happened here in the joints. Notice that there are two spherical joints. One of them at the bottom and the other one on the top. The reason the top one became a spherical joint because I put that point essentially on that curve. So I don't want that top one. Now this one is the top one between the inner and the dummy. I don't want this. If I had deleted that very last constraint right there, if I had deleted that very last constraint, which was to put the point on the curve, this would not have been created. But it did. I forgot to delete that, but I'm going to delete it now. And it says, should I delete that constraint too? Yeah, sure, why not? Delete it. Okay. So we have a spherical joint down here and a prismatic one, inner and outer tubes. Now we're going to do a point curve joint. There's a point curve joint. It's asking for a curve. Here's my curve. It's asking for a point, and the point is going to be this point that I created. Good. Notice that the degree of freedom became 2, and if I make this thing length driven, this point curve joint, if I make it length driven, degree of freedom becomes 1. This is the one degree of freedom that I said you cannot, you have to somehow put it away. And the reason this is happening is because this bottom is spherical and the top is point curve. So these two pieces can actually spin about their axis. I want to prevent that spinning about that axis of the tube, and that's where this guy is going to go away. And here's the trick that I'm going to be using in order to do that. If you go back to the slides here, it says, we're going to make sure that, let me see, I'll come to this in a second. I want to make sure that let's see now. I will make sure that a plane associated with the this assembly, when I say assembly, for example, the outer tube, a plane associated with that outer tube always goes through the same point associated with the dummy. If that is the case, that spinning motion, in a sense, is taken care of. So here is what this thing says. Where is that? Okay. It says, go to the part ground, which is in my case dummy, create a point on the plane YZ of the outer part. So let's do that. We go here, go to the part dummy. The part dummy is on the top, double click on it so that you are in this part. You are in this part, and whatever you create is going to be in this part, which is the dummy. And then create a point right there. See that? Create a point on a plane. But which plane? So you go from the outer part, you select the YZ plane, okay? And you can, this blue point is the one that is being created, and it's in the dummy part, by the way. I can put it in the center, I can put it anywhere. That's totally irrelevant. Totally irrelevant. So I'll just leave it there. I just created a point in the dummy. You can see that right there in the dummy, right there. And it lies on the YZ plane of the outer part. Now, how's that going to help me? So let's go back to digital mockup. What we are doing, I want to create a point surface joint. Okay, I want to create a point surface joint. The point is in dummy, and the surface is that YZ plane. So I click on the in the outer part. So click on it. It says, where is the surface? The surface is that YZ plane of the outer one that you created, you used to create that point. And the point is the one that you just created. And the reason we did this thing is that the point must be on that surface. And it is, because that's how we created it. And we say, okay. Notice that says the mechanism can be simulated. That's great. That 1 degree of freedom, DOF equal to 1, just went away. So first, let's go ahead and see whether we can actually do it manually. You see that? This is the 0 position, by the way. I'll put it at the 0 position. We say close. And then we're going to do simulation to make a basically animation and a cartoon. We do this. Because I put it at the 0 position, it is a 0 position. So we drag it all the way. Insert, rewind, anything but 1, and play it continuously. And there we are. So that's what the problem. The trick here, well, what you learn here is that that 1 extra persisting degree of freedom, which is happening between spinning of 2 endpoints, possible spinning of, but because of the nature of the endpoints, which is in one case ball socket, the other one was point curve, or it could have been ball socket, ball socket. So ball socket means that that piece in between can always spin, and this is one way to get rid of it. Okay, there are other ways of doing it. So let me stop this thing, rewind, okay, save everything. And now I'm going to do the second problem, which is my C-clamp, where I'm going to introduce you the screw joint. Okay, so first I'm going to make 2 parts. One is that bar basically with this handle, same part, and then the C-clamp itself. So let's go ahead and do that. For ignoring all dimensions, let's close this. So we start with a new product file. Okay, so let me switch to assembly design. I don't want to work here. So save it right away. File, save management, save as. And the reason I do this thing, I want you to go in an organized way on the final exam. So new folder, I'll call it C-clamp. C-clamp. Everything is going to go there. Oops. Where did that go? Right there. Okay, let's do the clamp first. So insert a new part in there. I'll call this thing the C, properties, C clamp. right there. And let's make it. Okay, on this plane, I will sketch something that looks like a C. It's not very elaborate. There. Exit. Pad it. All right, that's good. I want to drill a hole up there. Actually, a hole down here. So on this face, I will sketch. Okay. How about the circle? Like that. Exit. You make a pocket. Okay, that's good. And then on the top, I want to make a stand that looks like this. Okay. I mean, these are minor things that they don't have to be done like that, but that's up to you. So on this face, I will sketch. Why don't I project that circle? Just project that circle and continue with the rest. So let's see what we've got. Yeah, and then I pad it. That's too much, maybe by 1. Let's see. Yeah, that's good. And on that, I will sketch another circle that gives you the illusion of that, clamping area. So like this. Let me see for a second. Are these concentric? They don't have to be, but I would like it to be. Just control that. Make it concentric. Okay. Exit. And then pad it. A tiny amount, maybe 0.1. That'll do. Good. So basically, this is my C clamp. Okay, so let's go here to the top, save everything, insert the handle. How about that? Insert, insert, new part. Always say no. Okay, so I'm going to rename this thing properties, and that's going to be handle. Down here, handle. All right, let's go make it. Double click on this plane. I will sketch. Why don't I project the circle, which is going to get inserted. This handle is going to get inserted into this thing, and notice it got projected. So up, out. I mean, and pad it. Why don't I do this thing in both directions? Really doesn't matter, but okay, good. Now on that face, I will sketch. If I want to make it look like what I showed you in the slide, so I'm going to project that there, exit. These are all cosmetic things, but why not? Maybe you don't know, you learned something. Point 1. Okay, good. And then if I want a real handle, so I'm going to make it on that vertical plane, sketch. You see what my plan is? I'm going to draw a little circle here. Exit and pad it. There's the handle. If you want it also to go in the other direction, you click on more and use this other guy there. Very good. So we are done. It looks something like that. All right. Save everything. Go on the top. Save everything. Now, let me anchor the clamp. The clamp is anchored. And the reason I like to work in the assembly design workbench instead of DMU is that I have access to this move, as I said several times. So I'm going to translate this thing in the, how about doing it in the Y direction so that you can see what's going on. Okay, good. So this is fixed. Now notice that in the toolbar. Let's go ahead to the digital mockup. Actually, we want this thing to be inserted there, right? What is this coincidence between this and that, right? That hole, the axis of the hole, right there, and update. Okay, good. And this will become a cylindrical joint. You know that. If it's axis to axis, eventually it becomes cylindrical joint if you use the magic wand. So we go to digital mockup, DMU kinematic, digital mockup, DMU kinematics. Click on the magic wand, or new mechanism, auto create, and that better be a cylindrical joint. Cylindrical joint. Okay. Now, cylindrical joint have 2 degrees of freedom. The linear motion along the axis and the spinning. Okay. Now, if you look here, there is something called a screw joint right there. Screw joint, the spinning, the rotation of the let's say the handle and the advancement of the handle in that direction, they're related together by the pitch. Okay, so it is not a 2 degree of freedom, it's a single degree of freedom. So if you click on it, you see that it's actually asking for 2 lines. So I don't even need this. I can delete this. I can delete this joint. I'm not going to delete the children, but I'm going to delete this joint. No joint. The screw joint must be done manually by yourself. Screw joint. Click. It says line 1. Well, here's line. And let me hide this thing. Second line is here. And that's it. And the pitch is by rotating this, how much it's going to advance. And this is in millimeter. I could not change this thing. I don't know how to change it to inches or whatever. So let's hypothetically make it make it, how about 1 inch? But 1 inch is 20. Let's say approximately 20. Can't remember. Oh, I'll put down 1 inch. Let's see if it actually it won't let me actually type this thing. So I'll put down 25. That's going to be almost 1 inch. We say, and it's going to be length driven or angle driven. That's entirely up to you. So first of all, if I say okay, it's created and there's a degree of freedom 1 because I have to specify whether I want it to be length driven or angle driven. I'm going to make it angle driven so that I know that when this thing turns once, this is going to go up, for example, by, I don't know, 25 inches. Okay, so I'll put down 0, 3, 6. Mechanism can be simulated. Where's the handle? It's in hiding right there. Let's get it back. So if I go and do this thing manually, when I go 360 degrees, this goes up by almost 1 inch, which is 25 millimeter. actually, in this case, down. Okay, so what I had to do was to change the range going from, remember when I did this thing, let's go back here. Okay, so let's make this thing from this direction. Actually, you can flip it. Hang in there. Let's do that. This direction, see that? There's a blue arrow right up. Okay, good, good, good. I flipped it. I clicked on it and flipped. Oops. Hang it. Let's try it again. Double click on the screw joint. Click on that. Okay, and then say okay. I'm not sure why. Okay, so why can I not? Okay, good, good. I think this time it's going to go up. Yeah. And if you measure it, you see that this advancement is about 1 inch. Okay, that wraps up the concept of C-clamp or screw joint. Okay, good luck. See you next week.